With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, one end of a copper rod of uniform cross section and length 1.5 meter is kept in contact with ice. That means at one side the temperature is 0 degree centigrade because temperature of ice is at 0 degree centigrade, and the other end with water at 100 degree centigrade. At what point along its length should be a temperature of 200 be maintained so that in the steady state the mass of ice melting be equal to that of the steam produced in same interval of time? That means the mass of ice is equal to the mass of steam in the in steady state. Assume that the whole system is insulated from surrounding. That means there is no heat transfer between the system and surrounding, and the value of L for ice, L is latent heat. Latent heat for ice is given 80 calorie per gram, and latent heat for steam is given 540 calorie per gram. So let's start the solution. In the question they are saying that there is a copper rod. So suppose this is my copper rod having length 1.5 meter. At one end it is ice, so at this end the temperature is 0 degree centigrade, that is ice, and at the other end there is water at 100 degree centigrade. Now in the question they are saying that we maintain a temperature 200. Suppose this is the point at which the temperature is 200 degrees centigrade, and the length from 100 degrees centigrade is x. Length of this point is from 100 degrees centigrade is x, and from this the length will be 1.5 minus x. Okay, and we have to find out the length x. Okay, now the heat transfer from this point to ice is suppose q1, and the heat transfer to the water side is q2. Now first we have to calculate the heat. So the heat q1 which is transferred to heat ice in t time, heat transfer to ice in t time, and this is given by, we know that rate of heat flow, that is given as dq upon dt, which is equals to delta T upon R, change in temperature upon R. R is the thermal resistance, and the value of R is given as L upon Ka, where L is the length, K is conductivity, and A is cross sectional area. So I can write for case first the heat transfer to ice in T time. So it will be dq, or I can say Q1. Okay, so I can write this heat as Q1. So Q1 will be given as, temperature difference is 200 minus 0, and the value of R is L upon Ka. So it will be Ka 200 minus 0. It is 200 minus 0. Temperature difference is 200 minus 0. So 200 minus 0 T. This T is going this side. So T upon length is 1.5 minus x. From the ice end the length becomes 1.5 minus x. Now we know that heat transfer to ice is also given by q1 is also can be written as, that is equals to the latent heat. So I can write m1 LF, latent heat of fusion. Now both heats are equal, so I can equate both. So we will get Ka 200T upon 1.5 minus x, and that is equals to m1, and the value of latent heat of fusion is given, that is 80 calorie per gram. So from here the value of m1, that is the melted ice, m1 is coming out to be Ka 200T upon 80, 1.5 minus x. Suppose this is my equation 1. Now similarly we have to find out the heat Q2 which is transferred to the water which is at 100 degrees centigrade. So similarly Q2 will be written as Q2 equals to Ka, temperature difference is 200 minus 100 into time upon distance from this end is x. Now the heat given to water can also written as M2 LV, latent heat of vaporization, because water is changing into the steam in this time and both heats are equal. So I can also write Ka 100T upon X, and that is equals to M2. M2 is the mass of steam into LV. The value of latent heat of vaporization is given in the question, which is 540 calorie per gram. So now solving this, we will get the value of M2, which is the mass of steam, that is coming out to be Ka 100T upon 540x. Now in the question they are saying that the mass of ice melting be equal to that of the steam produced. That means mass of ice, that is M1. Now in the question they are saying that mass of the ice which is melted, that is M1, is equals to the steam produced. The mass of steam is M2. So equate M1 and M2, we will finally have Ka 200T upon 81.5 minus x, and this is equals to Ka 100T upon 540x. T cancel out, Ka cancel out, 0 cancel out. So finally we will have 2 cancel out, 254x is equals to 1.5 minus x. Simplifying this, we will have 108x plus 8x, and that is equals to 12. Further simplifying it, we will have 116x, that is equals to 12. So the value of x will be 12 upon 116, and that is coming out to be 10.34 centimeter. Okay, so the value of x, which is the distance of temperature 200 from the 100 degrees centigrade, is 10.34 centimeter. And if I want to calculate the distance from ice end, that is 1.5 minus x, so I can calculate that distance also. So the value of x is 10.34 centimeter. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.